triangles as well. But we are talking about, it's titled Angles of Triangles. So our learning targets. Students will be able to classify triangles by their sides, so the relationships that their sides have, and also by their angles. Students will be able to find interior and exterior angle measures of triangles. As a quick, our first quiz in this chapter, how many degrees does a triangle have to add up to?
What?
The angles of a triangle, how many degrees does it add up to? Do you remember? 180. Nice. Good. You guys passed the first quiz. Order of operations. First, we look at terms. We have a couple theorems, some examples, and practice. So this is a picture that you definitely 100% will want to have down in your notes. The top talks about how we will classify triangles by sides, by the relationships that their sides have. The second half of it, well, that's not good. The second half of it talks about how we classify triangles based on their angle relationships. So remember, you can use any notes that you write down from the lectures. You can use those during the test. You can't use pictures on your iPad from the test. You can't use the slides on the test. So we'll give a minute or two just to get these down. And make sure when you're drawing the triangles that you get all the tick marks that they have and any of these little angle signs here. Make sure you get everything down. How are we doing? We get these down, or do we need another minute? What? Like, according to what? No, you keep writing. I'll look it up. You keep writing. Urban Dictionary. What do they know?
Do you not know what that is?
I know what that is. What?
So you've never read Shakespeare, then? I'm gonna take your silence as a yes.
Oh. Obtuse, which comes to us from the Latin word obtusus, meaning dull or blunt, can also describe an angle or a person who is mentally dull or slow of mind.
So dumb.
The word also developed a somewhat controversial sense of hard to comprehend.
Well, it has 3 definitions.
It has lots of definitions. We go by its geometry definition.
Do we?
Yes, we do.
I know a few people who are kind of obtuse. Me.
That's not true. Nobody in here is obtuse.
Obtuse, size-wise. Me.
All right, are we good?
No.
No?
I'll do it while you're school.
Okay, so I'll just talk about, they're pretty self-explanatory, but I'll just talk about each one for a second. So the first 3 talk about how we classify the triangles by their sides, what relationships the sides have. So you can see with the scalene triangle, there are no sides that are congruent, so nothing really is going on there. That could be any type of triangle that doesn't have any congruent sides. With the isosceles triangle, that means it has at least 2 congruent sides. And then with the equilateral, all 3 sides are congruent. All 3 sides are the same. Okay? We only can know, even if they look like they might be the same, like this line and this line, kind of look like they could be the same. But how do we know for sure that 2 lines are the same? Well, the distance formula, true, but what if it's not in a graph? How do we know for sure that this line and this line are the same? This one and this one. How do they know that they're the same? Because they have little tick marks. Little tick marks tell us, that's the way to know for sure they are the same.
How do we know the tick marks are right? Yeah.
Well, we have to trust them. And then the next part, classifying angles. So the first one, classifying by sides. The second part by angles. Okay? And a acute triangle means that all 3 angles are acute. What does acute mean? Someone remember?
Small. Under 90
Well,
degrees.
small, under 90 degrees. Good. Yep. If we have a right triangle, that means we have one of the angles is you guessed it, a right angle. That would be a right triangle. An obtuse triangle means that we have one angle that is,
Bigger than the others.
well, larger than the other ones, but what?
More than 90 degrees.
More than 90 degrees. Yep. Obtuse triangle means we have one angle that is more than 90 degrees. Equilateral triangle means that all angles are the same. Okay? An equilateral triangle. Let's see who's on it today.
What?
If all 3 have to be the same, then we know that a triangle has to be 180 degrees. What does each angle have to be? 60. Nice. Each one has to be 60 degrees.
Do I get a gold star?
Yeah, here. You ready? Catch it. Catch it. Okay. Stick it on.
She wants an actual sticker.
I should bring my stickers. I have stickers. I can bring you a sticker.
Like cool stickers?
Yeah, teacher stickers.
Really?
Yeah.
Alright, bring them in.
Okay, I'll bring it tomorrow.
I'll start giving stickers instead of.
They also have like fruit stickers. Like
Sweet.
the teacher stickers.
Here, you get a pineapple.
2 years ago, and I have it on my mirror.
Yeah, I did give her a gold star. I still have
You
those.
get a pineapple. You get a pineapple. You get a pineapple.
There is a pineapple one. There's an orange, there's an apple.
It's distracting.
It's a lot.
It's distracting.
Wait, okay, but I still have to do it.
So we might get a question like this. It says classify the triangle by its sides. So using one of these three up here. Then determine, and now in this case he wants to determine if it is a right triangle. Sometimes they will say then classify it by its angle, but now they're saying specifically, is this a right triangle? So first, if we're classifying it, well, we're going to find out. First, we're going to classify by its size. So we found out that OP was 2.2, 6.7, and 7.1. So after using the distance formula, we find out what the length of each of those sides are, and are any of them congruent? No, none of them are. So what type of triangle would that be?
I don't know how to say that.
Scalene.
Scaling.
Would be a scalene triangle, because none of the sides are congruent. Now here's where things get really interesting and kind of come full circle, okay? We need to find out if there's a right angle in this triangle. Let's see, what's the best way to phrase this? What have we talked about so far on a graph? What types of lines form a right angle? What types of lines? Parallel lines?
Perpendicular.
Perpendicular. Nice job. Perpendicular lines form a right angle. Now, how do we, if we look at the slopes of perpendicular lines, what do they have to be so that we know that they are perpendicular? Slopes.
Oh,
No,
slope.
slopes.
I forgot what slope is.
Slope. Rise over run. What is the slope? They have to be what? We had a special word for what those slopes had to be. Kaylee, you remember?
No.
It started with opposite. They had to be opposite something.
Opposites.
Yeah. Read, sit, roll.
That is not even
That
say.
is
What does
not
that
even
say?
close.
What is that?
Opposite reciprocals, though, right? For it, if we knew to know for sure that two lines were perpendicular coming in at 90 degrees, they had to be opposite reciprocals. So, let's use a little bit of common sense here. Is there any chance that this is a right angle up here? That it is 90 degrees?
No way.
No way.
No
way,
way.
way too small. Is there any chance that this is a right angle?
Maybe.
Could be. So
Could
we need
be.
to check. We need to check the slope there. What about this one?
Maybe.
Possibly. So we need to check the slope of a couple of our lines. So let's start with the slope of OQ. OQ. If we just look at rise over run, right? We don't have to get out the whole slope formula, but just rise over run. We are rising from 0, 0 to 6, 3. We are rising 3 units, running 6, so our slope is 1/2. Positive 1/2. If we're going in this word line, we'd be going in the positive direction. Are we following?
Yeah.
We doing okay? Following? Okay. If we're not, that's okay. I just don't want to go too fast. Now, let's look at the slope of here. OP. If we look at the rise, we are rising 2 units. From 0 to 2. And we are running -1 units. So our slope is -2. So if we look at these two lines here, based on their slopes, would this angle be a right angle or not? One of them is 1/2 and
Yeah.
one is -2.
Yeah.
Why?
Because it's opposite.
Because they're opposite reciprocals, right? The other way that we thought about it is we said if we can take the slopes and if we can multiply those slopes together, what should we get? -1. So if we multiply, it's another check for us. If we multiply the slopes together, we would get -1. So we know that they are perpendicular lines. We know that they are opposite reciprocals. So, we did all this because it said determine if it is a right triangle. And we just found a right angle in that triangle. So we would say this is a scalene triangle if we classify it by the sides. And if we classify it by the angle, it is a right triangle. So we could just write right. Or yes, it is a right triangle. I know that was a lot because we found all those side lengths in our warm-up. but do we understand how we went through that? Okay, we'll practice a few like this, so you don't need to freak out yet. Now we have a couple of terms and things that we need to look at. When we're finding the angle measure, if you would like to write this down, you can. It's typically really, really obvious. But the sides of the polygon are extended, other angles are formed. So instead of just having our triangle, if we were to extend it and have full lines here instead of just the triangle, more angles would be formed. The original angles, so the inside of our triangle, are the interior angles, big surprise. Any angle that is formed on the outside, which you can see over here, would be exterior angles. So some pretty obvious, there's no way to try to trick you with that, okay? They're inside the triangle, they're interior. Outside the triangle, they're exterior. But we're going to use those terms when we're talking about these triangles, so I just want to get those out for you. I think she's got more quarters.
I did a drink, so I had to count exactly 150.
Nice.
How much it is.
Alright, do we understand interior, exterior? Good to move on?
Yeah.
Sweet. Now we have two theorems. Both of these, first one you probably don't need to write down the whole thing, but just know that, write down theorem 5.1, triangle sum theorem, and that means that the interior angles of a triangle are 180 degrees. So we said that in the very beginning, we know that, but now we're just putting a theorem to it. So it'd be good to write down just so that you know when we refer to theorem 5.1 that has to do with the sum of the angles on the inside of a triangle. The theorem 5.1 just says the sum of the measures, the interior angles of a triangle is 180. So this angle plus this angle plus this angle will always equal 180 for our triangle. And again, for that first theorem for 5.1, don't feel like you need to draw the picture, don't feel like you need to go crazy and write every word down. All it's saying is the sum of all our angles is 180 degrees. We already know that. We just give it a theorem. You good, Arissa? You getting these things down? Our next theorem, exterior angles theorem. This one is one that a picture would be really helpful for. I actually, for the second one, I wouldn't worry about writing the words. I would just get the picture down and that would be enough. The exterior angle theorem says that the measure of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. Now that sounds a little bit tricky, right? There's some weird words in there, but all it's saying, like it has in the picture, that's it. This outside angle, angle 1, we could find angle 1 by finding what angle B and angle A equal. So if I said angle B was 20 degrees, angle A was 40, then you would know that over here, angle 1 would be 60. It's those opposite angles. Do we have questions about any of those two theorems? I can see if you can try that before I show it. Can you give it a try? Or right down to that side. I can put these back up if you need it. So it says find the measure of angle JKM. So JKM. So we have to find the measure of this angle right here. Well, like we just said, if we take these angles and add them together, so 70 plus x, it has to equal this exterior angle here. So 70 plus x has to equal 2x minus 5. Find that x equals 75. Now it would be easy for us just to put 75 as our answer, but remember we need that angle measure. So x equals 75, that doesn't mean that that angle is 75 degrees. If we take x and plug it, or take 75 and plug it in for x here, 2 times 75 minus 5 would give us that angle. So that would give us 45 degrees. So that's a pretty straightforward application problem that we would see with that second theorem. We set up that problem and then solve for x. You guys like this theme?
Hello, character does not look like you.
It's not supposed to look like me, that's just what Kane said.
You can't customize it?
No. I mean, I'm sure I could find a way to put like, I don't know what would make it look like.
Well, he's not white.
Oh,
Play lost.
I mean,
And you don't dress like that. You dress
that's true. But everyone needs it.
It's a jeans store.
his body looks very unproportionate.
It is, yeah.
Yeah.
Huh?
Those are Jordans.
Those are jorts. I can pull off jorts.
Yeah, you can.
He's got skinny twig legs with a big old body. I just body shame the character.
You
All right.
fun body
So you do not need to write this down, but it's important to note. We're going to look at something called I'm so bad at saying this word. I don't know why I put that on the slide. A corollary. A corollary to a theorem. So it's like an extension of a theorem. It's a statement that can be proved easily using the theorem. So we're going to give a theorem, and then the corollary is the part 2 of that theorem.
That's cool.
Okay? So if we have a corollary to the triangle sum theorem, the triangle sum theorem, remember, said that when we add all the angles together of a triangle, then they equal 180 degrees, right? Triangle sum theorem,
Yeah,
right? Okay.
yeah.
The corollary to the triangle sum theorem,
How do you say it like that?
because I can't say it well, so I have to say it slow.
Just think of Coraline.
Corollary.
Oh my
The
God.
triangle sum theorem corollary says that the acute angles, so if we have a right triangle, the acute angles, so these other angles over here, if we add them together, they have to equal 90 degrees, which totally makes sense, because if our total triangle is 180, and we know that one side right here, angle C, is 90, then the other two have to add together to equal 90. So that's something that totally makes sense. I think we can grasp pretty quickly. You don't even have to write that down, but it's just something to note. We have some practice here. We're going to skip it.
Oh, that guy got a beard. Yeah, looks like Mr. Bangor.
That looks more like me, doesn't it?
No, that's Sale looks like Mr. Bangor. Yeah, it does. Look, this guy's got a man bun up here.
We're going to skip the practice, go right to the worksheet.
Oh my God. skip practice?
I think I put some extra problems on this worksheet. What? Did I not? Did I give one to Rissa? Oh, sorry. I put some extra problems on this practice.